All right, today we are looking at inequalities and graphing. So what you'll notice with inequalities is there is no equal sign in inequalities. You will see these symbols instead. So less than, and equal to, greater than, and equal to. So when solving for inequalities, we're using the same methods that we've used to solve equations. There are just two additional rules to follow. So you do have this under your modules, under the 6.7. So rule number 1 is dividing by a negative number. So if you're at the last step and you're dividing by a negative number, the inequality sign will reverse. So basically, if it was a less than sign, it will reverse and become a greater than sign. If it was a greater than sign, it'll reverse and become a less than sign. And that'll make more sense when we do some examples. Lastly is if it's a ratio type inequality, which we looked at last class, the rule is, it's still the same way I showed you, is you multiply your top left, multiply it by the bottom right, and you'll put that onto the left-hand side of the equation. And then you'll take your top right, no, you'll take your, it was top left and bottom right, and then you'll take your top right and bottom left, and you'll put that on the right hand side of the equation. And again, that'll make more sense when we look at examples. All right, so our first example here is 3x plus 7 is less than 22. So we're going to solve this just like we have our equations before. So we're going to do any opposite addition, subtraction first. So we're going to subtract 7 on both sides. And that leaves me with 3x is less than 15. All right, our next step is opposite of multiplying. So we're going to divide both sides by 3. And we end up with x is less than 15 divided by 3, which is 5. Okay, so we have our inequality here is that x is less than 5. So the last step here is drawing a number line like so, and we have to show that x is less than 5. Now there's two ways you can show this. So what I'm going to do is just label my number line first. So let's just do 2, 3, 4, 5, 6, and 7. So I've just started at 2. And the first way to show that is using an open dot. An open dot like this. And it's a less than 5, so that means you have to show that it's going less than 5, so towards the left. All right, if you're going towards the right, it would show greater than. So an open dot represents less than. The way it's shown in our modules is by a curved line. So I'm just going to put here or, and I'm just going to draw this out and just redo this. All right, so there's my number line, and they use a curved line like this. A curved, it's more like a curved symbol, and then it's still pointing to the left because it's still less than 5. The preferred method is this one, open dot. This is another method, but we normally see this top method. Okay, so a circle that's open like this represents, it'll be representing less than or greater than. If we fill in the circle, it's called a closed dot. It'll represent less than or equal to or greater than and equal to. So we'll see that as we do more examples. All right, our next example here, we have 7x plus 6.5 is greater than and equal to 27.5. So procedure is the same. We're going to solve for x. So subtract 6.5 to both sides. That leaves us with 7x is greater than or equal to 21. And then the last step, we're dividing by 7 on both sides. So we're left here with x is greater than and equal to 3. So our last step next would be to draw out our number line. And x has to be greater than or equal to 3. So I'm just going to draw out a number line like this. 1, 2, 3, and continuous. Because it's greater than and equal to, we have to use a closed dot. So all you do is at 3, and then we fill it in like this. That means the 3 is included because it's greater than and equal to 3. And which way is our arrow going to point? It's going to point to the right. That's where the numbers are getting greater than. So it's going to look like that. And the other method is shown in the modules is the same number line. 1, 2, 3, 5. This time it is shown as a line, straight line like that, and then the arrow is still pointing to the right to show that x is greater than, but it's also including the 3. So x is greater than and equal to 3. All right, so our next example, we have negative 4x minus 8, and it's less than 12. So again, we're isolating x just like normal. So let's do that. We have to add the 8 to both sides, just like that. And we are left with negative 4x is less than 20. All right. Here now we have a negative 4x, and this is rule number 1, which was if you divide by a negative number in the last step, the sign will reverse. So let's do that here. We're dividing by negative 4, we're dividing by negative 4. So let's just put a note here that the sign will reverse. Because we are dividing by a negative number. All right, so our sign is going to reverse here. We're going to have x is now greater than, and then 20 divided by negative 4 is negative 5. All right, so it reversed. From that less than, it reversed to greater than. So lastly, we just have to draw our number line. Okay, and I'm just going to start here at negative 6, negative 5, negative 4, negative 3. There's negative 2. And it's going to be an open dot because it's not included. So an open dot at negative 5. And it is greater than. So the arrow is pointing to the right. All right, so that means x can be any value greater than negative 5, but the negative 5 is not included. The other method to show that on the number line, again, it would be curved like that and pointing towards the right. All right, and again, this represents that x is greater than negative 5, but the negative 5 is not included in the answer. So our next example is a ratio type inequality. So in this question, we have to take our top left, multiply it with bottom right, and you have to place that on the left-hand side of the equation. So 7x times 3, that gives me 21x. And it's less than and equal to, we have to take our top right and multiply it with the bottom left. So it's negative 28 times 3, which is negative 84. All right, and our last step here to solve for x would be to divide by 21. And we end up with x is less than and equal to negative 4. All right, we did not divide by a negative number, so our sign just stayed the same. Last thing we have to do is graph on the number line. So draw your number line. All right, it is less than and equal to negative 4, so you would use the closed dot. And it is less than, so it is going to the left, like that. And the other way to show that is the straight line. The straight line represents that negative 4 is included in the answer. So just straight down at negative 4, just like that. And it's still pointing to the left to show that it is less than. All right, so let's take a look at this example. We have 4x minus 6 is greater than and equal to 5x minus 8. So I'm going to show this two ways because you might have moved the 4x to the left side or you might have moved the 5x to the left side. Either way, you would end up with the same answer, and I'm just going to go over both methods. So the first method I'm going to go over is I'm going to take the 5x and move it to the left side. So if I subtract 5x, subtract 5x, I end up with negative 1x. 4 minus 5x gives me negative x. Then I have minus 6, and it's greater than and equal to negative 8. And then I'm going to add the plus 6. To both sides, and I end up with negative 6. Negative x is greater than and equal to negative 2. And then here, because it's a negative x, which means it's a negative 1x, I do have to divide by negative 1. I have to divide by negative 1. So here is where I have to flip my sign because I'm dividing by a negative number. So I end up with x is less than and equal to positive 2. Negative 2 divided by negative 1 gives me positive 2. So the answer is x is less than and equal to 2. All right. You may have done it the other way, so I'm just going to quickly show that way as well. So same question. It's 4x minus 6 is greater than and equal to 5x minus 8. So in this situation, you might have subtracted. So, all right, so moved the 4x to the right. So we end up with negative 6 is greater than and equal to x minus 8. So here 5 minus 4 gives me just 1x. And lastly, I just have to add 8 to both sides. So negative 6 plus 8, that's 2. And it looks like this. All right, so if you leave it like this and you read it, it's the same answer as this one. The only difference is x is on the right side and here x is on the left side. But if you read this from right to left, x is less than and equal to 2. Same here, x is less than and equal to 2. So the only difference here is we're reading it from right to left because x is on the right side. X is less than and equal to 2. So you could rearrange this just to read it the same way we always do, which is with x on the left-hand side. So x is less than and equal to 2. All right, and the last step here would be to put this on the number line. So 0, 1, 2, 3, negative 1, negative 2, negative 3. So there's my number line. The 2 is included in the answer, so we close dot, and it is less than, so we would be drawing that to the left.